All right, so this is the second day of slope, and this focus is on, this assignment focuses on the rate of change. And also, if I have slope, how do I find a missing coordinate? So just the other two aspects that we talked about in the notes, kind of separated it. Yesterday, we just worked with straight up slope. And so when we were doing just slope, we just had the slope formula. We're going to still use this formula today. So I suggest that you put that on your top of your worksheet, just like I did there. Okay, it's going to be used, we're going to use it for rate of change. So when you do rate of change, though, usually for a rate of change, we actually divide it out and we get a decimal answer. If it is a decimal, it might be a whole number. But when we are graphing and we're using slope, we want to keep the fraction because we want to know how much we're rising and how much we're running. But when we're dealing with rate of change, it just makes sense to say how much per year, not per 25 years, or how much, per hour, not 10 hours. So it just depends on the data and what you're looking at. So rate of change has a story. Rate of change isn't always constant. It can change a little bit. So in this first example, I'm just going to do the women, and then you guys will go ahead and complete the rate of change for the men. But it's showing the predicted life expectancy, how long men and women are supposed to live based off of the year they were born. Okay, so for this first one, part A is asking us to, just want to change here we go. Find the rate of change for women, 2000 to 25. Now, when they do rate of change, you can't just pick any two ordered pairs. You have to look at the actual information. What I'm going to do is I'm going to back up and I'm going to write these as ordered pairs so it makes sense to you. Anytime they give you a word problem, I'm strongly suggesting doing that. So we're looking for the rate of change for women. So women is the one with the boxes. So I look at the graph. I'm looking from here, this ordered pair, all the way to 2025, which is this ordered pair. Now, they may have said from 2000 to 2050. Okay, so they're looking at those two ordered pairs. They want to know how much it has increased. I know it's increasing because it's rising to the right. So I'm going to write that as an ordered pair. This is my x coordinate. This is my y coordinate. So the first ordered pair I have is 2080, meaning in the year 2000, if you're born in the year 2000, they're estimating that women will live till they're 80. And if you were born this year, 2025, they're estimating, hopefully, that these little baby girls will live an extra 4 years longer. Okay, so then we want to know what's the rate of change. And so we have to look at over the 5 years, or the 25 years, 4 years of increased life expectancy. We just use the slope formula. Okay, so remember, you got to do the y minus y on top, the x minus x on the bottom. So just use little loops. And I'm going to put 84 minus 80 on top. And if I start with 84, then I have to put 2025, the year, on the bottom, minus 2000. That keeps everything positive. I know it's going to be a positive slope because the life expectancy went up. So 80, take away 84, take away 80 is 4. And then taking away 2000 from the 2025 is 25. So when we actually calculate that out, 4 divided by 25, take my calculator, just type it in. Don't use the fraction button this time. We're actually going to divide it out. 4 divided by 25 is 0.16 per year. So they gain 0.16 of a year per year, if that makes any sense to you. I know it's kind of weird to think about 1600ths of a year. So a couple months each year for those 25 years they gained to collectively add up to 4 extra years of life. But this is what we're looking for, the decimal version of that. So everything else is the same. We do everything like we did before yesterday. The only difference is we actually divide it out when we deal with rate of change. Okay, and then we look at part C. Part C is saying from 25 to 50. So for 25 to 50 now, we're looking at in the year 2025, the life expectancy was 84. So that's babies, girls that were born to this year, they should live to 84. And then the babies that were born in 2050, if they're girls, they should live till they're 87. So they gain yet another 3 years, a total of 7 from anybody born in 2000. I think they're basing this on like advancements in medicine, healthcare, education, on taking care of our bodies. And then if you notice, the whole male line is slightly lower, and that's just historically what happens. Okay? Women usually, typically, outlive men. Not always, but typically, statistically speaking. All right, so we're going to find the slope again. I was going to do the 87 and the 84 on top. 87 take away 84 on top. I started with 87, so I have to start with 2050 and subtract the 2025 underneath it. I want to see this work. That's why I'm showing it to you. Whatever I do, you do. 87 take away 84 is 3. And 2050 minus 2025, and I can do that math in my head, we're not going to leave it as 3/25. If this was a line, if there was no story, we'd leave it as 3/25 as a slope. But because it's a living life expectancy rate, we're going to divide it out. And that means they gained another 0.12 months every year. 0.112 per year is what they've gained. And so collectively that added up to another extra 3 years. And you have to just be careful because they could have said, okay, well, how about from 2000 to 2050? So you just have to read the directions and be very careful because they will not all give you the same data. As you can see here, Part A and Part C gave us completely different rates. Good news is that both of the rates are going up. I know that has been also talked about in the news, that maybe it levels off or it starts declining. The decline would be awful. That would be where the people in the future aren't living as long as we are. Life choices or pollution or whatever may be the factors, lots of different factors. So you guys are going to finish B and D all on your own eventually. Let's skip down. I just want to give you some clues on number 2. You're going to do number 2 all by yourself. But when it's given to you like a story problem, we have to make ordered pairs out of that. So a daily newspaper had 12,125 subscribers. Okay, that's how many people are getting the newspaper. When it began publication, that's time. 5 years later, that's time. It had 10,100 subscribers. Okay, so I got subscribers here. I got time 5, and I have began publication. That is time. It's just a weird way of looking at the time. What is the average yearly rate of change in this 5-year period? So basically, they're just asking for the rate of change right here. So you're going to find the slope, and then we're going to divide it out. So I know one of the ordered pairs, 5 years later, there was 10,100 subscribers. If you remember back from the little warm-up we did yesterday, we talked about your x-intercepts and your y-intercepts. The 12,125 is your y-intercept when we began in year 0. Okay, 5 years later, we can call it year 0. Now, we're not saying that it was year 0 in terms of like BC or, the actual year 0. It doesn't really matter. We just say 5 years later. If you would like, you could say that this year was the beginning. If it makes more sense to you to really have an actual year, you can pick any year you want. But just make sure that the next in 5 years, this would be into the future. You could have said the year in 2000 and in 2005. They have to be 5 years apart. So we have to have a beginning year. We don't know what year it was. We'll just call it year 0. And then 5 years later is 5. But this is also okay if that makes more sense to you. Okay? Set it up. What's crazy is both of these, this scenario or this scenario, will give you the same answer. You're going to divide it out and get a decimal. Okay? I'm not going to do that part for you. The second half of this lesson is all about the fact that they gave us the slope. Somebody already figured out the slope. And they want you to go back and figure out what is one of the missing coordinates. In some cases, like in number 3, we're missing the y coordinate. But in number 4, you're missing the x coordinate. It doesn't matter. It just matters where the variable ends up being. Okay, so we'll kind of do a little bit of each, and I'll kind of help you through that. So we're going to do number 3 together right now. We're still using the slope formula, just slightly different. Okay, so when we use the slope formula now, we're going to use it as a formula. I'm going to actually write it down just so we can see the variables. Okay, and when I talk about a formula is just a bunch of variables that we replace with numbers. So I can think of this as the formula and then replace what we have. We have 2 x's, 2 y's, and we have the slope m. It says right here, m equals, right, 1/2. So I'm going to replace the m value here with 1/2. I have 2 y values. One of them I know is 7, and the other one I don't know, which is the r. So I can do 7 minus r, or I can do r minus 7. I'm going to prefer to put the variable first, because we always have to give our answer as a positive variable. So by putting it second, you'd have that minus r. That actually turns into a negative r. So I'm going to do 7 minus r on top. That's my missing coordinate. And then since I started with 7 on the top, I have to do the 6 on the bottom first. 6 minus a negative 2 becomes plus 2. Okay, I'm going to just go ahead and replace that. Do that math in your head. Cross it off and replace it with 8. Okay, 6 plus 2, I see it there. I can still see it, but now it's an 8. And now we have a fraction equals a fraction. We can solve this proportion, right? So we're going to go ahead and use the whole idea of proportions now to solve. So I'm going to do the cross products of these two. Okay, so I have 8 times 1 is 8. I'm just going to show my work right next to it. Equals 2 times the quantity 7 minus r. 8 equals, we got to distribute. 2 times 7 is 14. 2 times negative r is negative 2r. I'm going to subtract the 14 over. Negative 6 equals negative 2r. I'm going to divide by negative 2 to get the r by itself. This is all from chapter 2. R equals positive 3. So we found that the y value that was missing would have been a 3. So just slightly different, using the slope formula in a different way. Let's go ahead and try number 5 again. Okay, so they gave me my slope is negative 9/2. So I'm going to plug that in for m. This time, here's my y minus y. It looks like I'm missing the y value again. And then we have the x minus x. So I'm going to put the r value first, always. Whether it's x or y, I'm always going to put it first. Okay, and so negative 9/2, that's my m value. That's my slope, is equal to y minus y. I'm going to start off with the r again. R minus the negative 4 becomes plus 4. And then if I started with r, I have to start with negative 5 on the bottom first. Negative 5 minus a negative 3 becomes plus 3. Again, I don't need to write all that over. If I can just do this quick little math and call that negative 2. I'm okay with that math. You're showing me how you got the negative 2, as long as you don't completely destroy it where I can't see it. Okay, so now we're going to go ahead and do the cross products here. You got to choose who you want to keep the negative. I'm going to make it negative 9 times negative 2. One of those numbers gets the negative, either the negative 9, or you could push it down with the negative 2. I prefer to keep it with the 9, then I don't have to distribute it. You just can't put it to both. And then this is an r plus 4. Let's put it in parentheses so that we know that we have to multiply the r and the 4 by 2. Okay, so those are my cross products. Negative 9 times negative 2, I'm going to just put it next to it, is 18. 18 is equal to 2 times r plus 4. Okay, and that means 18 is equal to 2r plus 8 when we distribute. And now we have a two-step equation. Just like chapter 2, we take care of the thing furthest away first, subtract 8. 18 take away 8 is 10, equals 2r. Divide by 2, r equals 5. So the missing coordinate there is 5. One last time, number 7 together, you got a negative 1/5. So my slope is negative 1/5 is equal to, I'm going to do y minus y first. Those are my 8s and 7s. I'm going to make sure that I know where my r value is. So because r is with the 7, and I want r to go first, so this is my x coordinate. On the bottom, I'm going to do 7 first. So I know it's negative, but 7 minus 8. And I did that because I pre-planned ahead and said I want the r to go first on the bottom. R minus 11 on the bottom. Okay? It's not bad if you do it the other way. It's just a little bit more complicated because the r value will be a negative. We're going to cross multiply those. Again, you got to choose where that negative goes. I'm going to put it with the negative 1. Probably could have done the 5. That's okay. Negative 1 times r minus 11. 7 take away 8 is really a negative 1. So I'm going to do 5 times negative 1 as well. 5 times negative 1 is negative 5. And then I have negative 1 times r minus 11. Write that down. Distribute the negative 1 through. Negative 5 equals negative 1r plus 11. Probably could have got rid of that negative with the 5, but I didn't plan accordingly. Subtract 11. I get negative 16 equals negative 1r. This is one of those where I don't need to see the work, but you still have to simplify in terms of positive r. So if a negative r or a negative 1r equals negative 16, change the sign of the r and change the sign of the 16. You can only do that when it's a 1, when it's a negative 1. So in this particular case, the missing coordinate for that x-coordinate would have been 16, working backwards using algebra. The only other thing I want to mention in number 8, if you want to quickly, they gave us a slope that's a whole number, but we're going to get a fraction with our formula, right? So let's go ahead and just make it a fraction, make the whole number a fraction, then we can get that proportion like we usually do. All right, this is due at the end of the hour because we didn't correct anything. I didn't have to check your notes. You have plenty of time to finish this if you are focused. If it's not due and not complete at the end of the hour, it is considered late.